When you step out of the college, do you want just a degree or in skills of an experienced engineer who is ready to build a smart factory? The truth is, most graduates enter the industry as a fresher who needs months of training, but the industries don't wait. They expect engineers who can build and contribute from day one. At NIMS University, the vision was never just to teach, but to transform the education into launchpad for the future, a future where the students not just learn about the industry 4.0 but live it. And that vision found its reality with Ausweg. Together, we have built a smart manufacturing lab, a fully automated end-to-end factory setup. This isn't a classroom upgrade. It's a bold step into a tomorrow where the learning meets innovation and the students step into industry before they even graduate. The process begins with the Automated Storage and Retrieval System or ASRS, designed with 5 vertical rows and 3 dedicated columns. It organizes inventory into raw materials, finished goods, and defective goods. Each item is mapped in real time, ensuring fast retrieval, zero manual error, and optimized space utilization. Once a request is triggered, the autonomous mobile robot comes into play. From its charging dock, it receives the wireless commands from the central control system, guided by onboard sensors. The AMR navigates to the ASRS, logs into the required raw materials, and then delivers them securely to the production line. This synchronized interaction between the ASRS and AMR marks the start of the fully automated production line. The autonomous mobile robot arrives at the CNC Turning Station carrying the first pallet of raw materials. Here, the AMR docks precisely with the station's conveyor, aligning itself for seamless transfer of materials. Automation takes full control. A Delta 6-axis articulated robot grips the workpiece with accuracy and loads it into the CNC machine. In addition to loading, the robot also performs flipping operations, rotating the material when required, ensuring both ends are machined with precision. This dual handling eliminates manual repositioning. Inside the CNC, the transformation begins. Facing operations create a flat reference surface. Turning reduces diameters and shape the contours. Finishing passes deliver exact tolerances and smooth surface finishes demanded in precision engineering. Meanwhile, the robot works in sequence with 2 materials at a time. As component undergoes machining, the raw material is already being prepared, ensuring continuous workflow without downtime. Once the machine cycle is complete, the robot retrieves the finished part, flips it necessary, and makes it onto the receiving conveyor. The AMR, waiting nearby, collects the component and immediately moves it to the next production stage. This synchronized workflow with the AMR, the Delta articulated robot, and the CNC ensures maximum efficiency, precision, and uninterrupted production. The part now arrives at the CNC VMC station. The AMR docks with the precision, lining perfectly for the transfer. Here, a Delta 6-axis articulated robot takes charge, gripping the component and moving it seamlessly between the conveyor and the machine. Inside the VMC, vertical machining operations begin. The spindle drives tools with high speed and stability. Drilling operations create precise holes. Tapping follows, cutting accurate threads that guarantee reliable assembly. Each motion is controlled through pre-programmed toolpaths, ensuring consistency across every single component. As one part is being machined, the robot prepares the next raw piece. This parallel handling removes idle time and keeps the workflow uninterrupted. Once machining is complete, the robot unloads the component and places it back onto the conveyor. The AMR waiting in position, picks it up and continues the journey towards the next stage of production. This integration of AMR, Delta Articulated Robot and CNC VMC delivers accuracy, repeatability and efficiency, ensuring high quality output with zero downtime. Next, the AMR transports the machine part to the manual quality check station. Here, human expertise meets automation. Students inspect each piece, checking dimensions and finishes to ensure industry-level quality standards. The component now arrives at the assembly station. Here, a CR5 Collaborative Robot designed for precision assembly takes charge. Equipped with a screw feeder and the automated screwdriver, the cobot ensures a reliable and a repeatable process. Step by step, the CR5 picks screws from the feeder, aligns with accurately, and tightens them to the required torque. Its advanced force control guarantees that every screw is fastened screwly without damaging the component. With its collaborative design, the CR5 operates safely within the automated line, delivering both speed and accuracy. Once assembly is complete, the AMR collects the finished part and transfers it directly to the vision station for final inspection, ensuring a smooth flow to the next stage of production. After assembly, the AMR delivers the part to the vision station. Here, advanced cameras and the AI-driven inspection systems scan every surface, verify dimensions, and confirm all screws are securely fastened, detecting even the smallest defects. Approved parts are sent to the finished goods column of the ASRS, while rejected parts move to the defective goods column, ensuring full traceability. This is more than machines in sync. It is a live showcase of advanced manufacturing, from robotics and machining to collaborative assembly, AI-powered vision, and wireless control. Students don't just see the future, they live it hands-on as industries transform today. After its cycle, the AMR returned to its charging dock while an IIoT dashboard oversees everything: production, machine health, and remote control. We extend a heartfelt thanks to NIMS University and the Prolin team for this incredible opportunity to bring the Smart Manufacturing Lab to life. Imagine a place where engineering students don't just study technology, they live it, where they become the driving force, the backbone of innovation, building solutions that industries demand today. Engineers don't wait for the future, they build it into the lab. They can create Industry X.0. If you want to build a smart manufacturing setup like this in your institution or industry, contact Ausweg Skill Forge today. It empowers students, educators, and the institutions to thrive the age of Industry X.0. Together, we shape the future.